Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Welcome back to the Digital Enterprise Society podcast. Thank you for coming along on this journey of this new show that is designed to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to be the co-host of this show, along with Craig Brown, who is a former General Motors employee and an industry leader in this field. Hey, Craig, how are you today?
I'm great, Tom. A little cold and rainy in Michigan, but besides that, it's good to chat with you again, and I'm looking forward to our guest today.
Well, it's cold in Michigan, and it's 100 degrees and humid in Austin, Texas, so hopefully our guest is going to fall somewhere right in the middle of that, and he is just going to be perfect. So today, I'm really excited about today's guest because he has a lot to share, and each week, we try very hard to bring to this podcast interesting interviews that will help our listeners enhance and grow their careers, and today is no different. We have Atilla Lengyal, and he is the Director of Strategy, Innovation, and Data Analytics at Western Digital. Now, he recently presented at Seimens Realize Live conference, and he's going to talk a little bit today about what he presented there. And one thing that really stood out to me about what he said that was in the promotional material about his breakout was he was going to focus on lessons learned and delightful insights in and around the march towards the fourth industrial revolution. So Atilla, welcome to the Digital Enterprise Society podcast.
Hey guys, this is Atilla. Thank you for inviting me. It's pretty exciting to be here. If I look outside my window, I think I have about 90 degrees and pretty dry, really nice sunshine. I'm in the Silicon Valley.
You're right in the middle. Well, the weather's always perfect in California.
I think I'm the luckiest in terms of weather right now.
So what is your story? Give us a real quick kind of synopsis of what brought you into this industry.
I was really always very passionate about manufacturing systems, and I was lucky enough to start actually, I think I was around 2021 when I started in this path, and ever since I was lucky enough to always have a job focused on factory optimization.
And so, it's interesting, you know, Atilla, when we were getting to know each other, you mentioned a reference, an author, and I hadn't heard anybody mention it in years. It's really interesting. Could you expand a bit on that? Who told you about that, and what did it provoke you to do?
You know, I was just a regular college student. So I was around 20, so I think you have the image very well made in your head. And you know, I had a really interesting professor I really loved. I always loved to go his lessons and classes and do always the homework. Now, at one point, he looked at me and said, "Here is a book, and Goldratt the Goal. Please read it." It was, late 90s, and he asked me always about it. What do I think? Why this book has become such a great success, and why people really learn from it. And that book really taught me. That was my first eye-opening. How simple it is. Factory optimization, in the end, is very simple.
Yeah, and to all your listeners out there, if you don't know what Atilla and I are talking about, I encourage you to Google Goldratt, Goldratt, and you will find a series of books. They're great reads. Get them, and they will teach you everything you need to know about optimizing not just factories, but also optimizing engineering processes. The same principles applied. It was 1999 that I was required as a GM manager to go through all of those books. It was really interesting. I didn't expect that.
I read it in 98. Actually, yes. If you look at ever since, I am really, really fascinated about manufacturing system and optimization. I was always keeping my focus on it, and even my operation research at a previous year, I was almost falling out from the class. The next year, I was in top of the class just because of that one book, one starting conversation about manufacturing systems, and my professor being mentor. And he took me to a lot of interesting factories. One of the factory I visited early, it was an Audi factory, one of the world's biggest engine factory. It was fascinating to see the production. And ever since, I'm just, hooked up to it.
So how did you get to Western Digital?
That's a little bit longer story. Actually, in Hungary, I started my PhD in the same field. But then I got an invitation from Japan, actually from the Japanese government, gave me a scholarship to study in Japan and get my PhD there. I started at Kobe University. It was really interesting. I mean, you're just landing like in the moon, right? I mean, you live in Europe, you grew up in Hungary. Actually, I lived some years behind the wall, right, in the Soviet area. We were not part of the Soviet Union, but of course, the country was very similarly minded. After that, landing in Japan and getting the a word differently and looking at it. Now looking it back, it was just an amazing experience. Then I started to work in Japan. I got my PhD. I started to work at Hitachi. Hitachi Limited is a very interesting company. They have the biggest employer in Japan, 120 some years history, and they have built in their training methodology. They built in everything. And I actually landed the job at the research institute there, and I worked with several subsidiaries at Hitachi. Hitachi has over 800 companies, and out of that, we had fabs, we had different factories, equipment manufacturing. So there, I really get to the nuts and bolts. I actually, 3 months, I needed to work as an operator in a factory. Can you imagine? You get a PhD in Japan, and back in Europe, my friends, they're getting their, cars, everything is paid for them. I got a bicycle to be an operator in a factory. But then, I learned a lot. So I ended up at Western Digital Corporation when from Japan, I became an expat in the Silicon Valley. And once my expat position was over and, Hitachi wanted me to go back to Europe or Japan, I decided to stay in the Silicon Valley and I joined Western Digital Corporation.
Excellent. And then tell us about Western. Where did it come from and where did it go? Western Digital. It is an interesting story, but I want to hear it.
It is a very interesting story. I think up till like 20 years ago, Western Digital was a very small company. I think annual revenue about 2 billion. We had only a product, 3.5-inch product, mostly for the Xbox, and a very small company. And even earlier than, it was just a component supplier for IBM. But I think the company had started a very nice growth path, made really good technology bets. We're betting on the 2.5-inch notebook market, and that's where actually the company grew a lot. After that, to keep building on technology, they acquired Hitachi Global Storage Technologies. That's where I kind of know, and Hitachi was acquired IBM. So as you know, the consolidation and the hard disk drive manufacturing business, now we have only 3 left, Seagate, Toshiba, and us. So that's really how Western Digital actually grew. And I think 3 years ago, we acquired SanDisk as well. So now Western Digital has become a really big, one of the biggest storage company in the world.
Now, let's talk a little bit about your paper at Realize Live last week. Thom picked up on the byline of it, and it intrigued me. And then when I realized what you were talking about, I found this picture at the back, that's your spiral picture. And at the end of your presentation, you talked a bit about that spiral. So you and I know what we're talking about, but you should describe it first, and then describe what it takes to get started. I thought you had some very interesting insights.
Yeah, I think these are the delightful insights that Thom was talking about. We definitely learned a lot of lessons. Let me just a little bit elaborate on how did it ever started. I mean, this is not an easy path. How to get to the spiral and what we really discussed. So think about the large organization like Western Digital Corporation, 70,000 people, different legacy business units, different approaches to operations, how it actually decided a year ago about to create a centralized organization, and this is the Digital Analytics Office that I lead the strategy and innovation of, to look at it, what can we do to really, really use advanced analytics to our internal operation benefit. That's really, but even for that to get there, it was a very tough road because we had to work as network. We had to really align all the players to actually establish this organization. Now, once we established, we did understand that we have to start small. Everybody, you can hear a lot of discussion about start small and, think big, but start small. Now, I even add one more thing and scale quick, right? That's the third part. So think about when you start small, what does it mean? Whenever you try to optimize something and whenever you try to improve something, as long as you don't impact the business value, don't add business value, it will be very, very hard to increase the scope. It will be very, very hard to scale. So my recommendation is that don't start really, big. Don't start even just, with millions of dollars investment. That's not going to work. It's never works. You have to start very simple. You have to start with an idea. What exactly you want to improve and why, right? So you can't really go about a fascinating technology and download a neural network somewhere and then start to create a model, download the model and watch YouTube and start from the technology point of view. You always have to start from the business point of view. And that was really my key insight. And it's really delightful because once you drive that, there is nothing stopping the investment because you exactly know what you want to improve. You have an idea how you want to improve. And to prove your point, you don't need millions of dollars investment that it can be done. You can start with a Raspberry Pi, or you can start with very simple. Even I remember my first factory optimization approach was starting on my laptop, which is like ridiculously low power. And I controlled an entire semiconductor fab using my laptop because compute become pretty good. And then, if you do really, you don't need to think really start very big. And you start and you close the loop. You always close the loop. You have a problem statement, you diagnose, you learn, you create prediction, and you optimize. And as long as you can't close this loop, you will not be successful. And that's really the lesson learned. You have to, and if it's even just 100K, that's perfect because you didn't invest anything. Now, after 100K, now you can scale and you can say, guys, I have done this. Look at this. Now let's go one more round and one more round. And you start to actually scope out and actually start to scale quickly. That's the way to scale, and that's the way to approach this.
A lot of times people don't agree on what first little idea to pursue. Did you run into that problem? And so how did you get consensus to move in a consistent direction?
Skunk work.
Okay. Well, that can work.
To be honest, you need to place your bet. So that's you have to be sure. That's why you can't really do it from. We do believe that it's important to have an SME, right? So you have to understand what you're doing. The technical portion you can either learn or you can get help. But if you don't exactly know from the business point of view what you want to improve, and you can't really explain that, you don't have your story right, then no matter what technology you will deploy, it's not going to happen. So I would say our priority is who we work with and how much promotion we get from them, how much support we get for them, and how ready they are to change. Because no matter what, once you optimize and you want to save cost or improve another business metrics, change will be necessary. So don't go for the amount, but go with the partnerships, create really good networks, explain everyone, get your story very good, and explain everyone why they need to change. Once that happens, the algorithm can be as simple as 1 + 1 is 2.
Yeah, and I think that's the key is the stakeholders need to understand how it improves the business. I see a lot of tool improvement projects where people say, well, it's automating my job and eliminating me, but I don't get how it helps the company, or furthermore, I don't understand how I'm going to be impacted, or I'm afraid I'll be impacted in a negative way. Did you ever have to deal with that kind of organizational resistance, or maybe it's more personnel resistance, where people were just afraid?
I would say I have two different views to this. One is that started a year ago, since we have the central organization and we have built business processes. We spent days, weeks to build the entire business processes of how we're going to operate. Since we have done that, I don't find this fun. We have a really good business process how to approach this. But let's say a year before that, or since my career, let's say 20 years ago, I have dealt a lot of resistance. There are systems that it took me 10 years to implement. In one of our factory, which is actually where I'm sitting, it's almost my home base. And I go to Shanghai, no problem. 2 weeks, I can explain everything very well. Somehow it's interesting that where people feel that they are most confident, they might have the biggest resistance because this is my home field, right? So I know everyone here, and it's yet so hard to make them change. And where else I go to a factory where I've never been, I'm very businesslike, I'm very right point on, very good communication. But yes, in this factory, I have dealt with a lot of resistance because people don't see the objective, the benefit. But I can say now, looking back, it was my fault. I was not clear what exactly needs to be done. So, it's easier to complain and find scapegoats. I do believe the resistance comes because of lack of communication and story.
And communication's a two-way path. I mean, they have to be willing to listen. You have to communicate well, or I have to communicate well. And then there's this third aspect, which is they have to really comprehend, right? And at least in my experience, that's been part of it. They many times don't comprehend, especially when it's a rather radical change that just may eliminate the need for their human job because we're replacing it with some sort of digitization. Do you have any advice for folks that are 20, 30 years younger than you and I that are entering this fourth wave of industrial revolution, and maybe what would your advice to them be?
Yes, it is a journey. It is a learning curve, and it is a journey. Actually, right now we talk about Industry 4.0. I'm sure that after a while we will talk about something different. In our time, we talked about flexible manufacturing or adaptive manufacturing. I can actually have so many keywords. The keywords never matter.
Good point.
What we're trying to achieve, and that's really what my suggestion is, always focus on productivity. A factory core objective and even operation, and I think even a business organization, it's all about productivity. So wherever productivity can be improved, and whatever buzzword we can use here, productivity can be improved, be focusing on that one and understand the technological background, how to improve productivity. For example, if you talk about PLM, I think, and I don't know if I can mention names of companies, but there are companies out there that are very sharp focused on the PLM, digitalization, why it matters, how it can improve. And I think in my presentation, I discussed this one. If we look at a modern factory, and we have few here too at Western Digital Corporation that is light off. You look at the robots, you look at, or even you can't because the light is not on. But when you look at those very high level automation, and my suggestion here is that if an industrial engineer is up there to actually improve and automate factory floors, then we data scientists or data analytics or PLM experts, we are out there to automate engineering offices. And then we call it light of engineering office. It's not that we will not need engineers. This is not because we will always need creativity. What we need to really focus on is to improve productivity at every level. We need to improve productivity through digitalization from the entire life cycle of a product, which starts the idea and get into the production, and then the end of life of the product. This cycle is where a lot of tremendous opportunity out there still to improve the productivity. And later on, we might call it Industry 4.5 or 4.6 or 5.0. It's not that. It's productivity improvements.
And for everybody listening, productivity is so much more than just what you as a group or you as a person can do. It gets down to the profitability of your company.
Absolutely.
And depending on the field you're in, storage devices that Western Digital does is quite competitive, and the cycles just get shorter and shorter. So that's why productivity has to be such a focus. One other thing I might add is just also, it's amazing the parts of our job that are unproductive, right? Like the administrative stuff and the record keeping and the configuration management and sharing of configurations. Well, all of those things are ripe for digitization. They really should be done with a computer or a series of computers, or even an agent or an assistant behind the scenes helping you. And I don't mean another human. I actually mean, a digital assistance. So don't be scared of productivity gains. Get back to doing real engineering, right? Yeah. The creative part of engineering. That's one of the great things about productivity gains. It'll free up time to go do the fun stuff you first learned, the reason you became an engineer.
Now you're talking about the closing of my presentation.
Okay. Well, maybe you should tell us the punchline.
No, let's go back a little bit on productivity, because I liked where you're going with that one. It is really interesting that, as again, a delightful insight that we learned, there is no one fit for all. This has to be very clearly stated. People think of smart factories as an idealistic way, meaning that you go into the factory, everything is robotized and everything is working well. If there is some trouble, everything is being resolved automatically. This is somewhat an utopistic view. In some cases, this is pretty productive, but in some cases, it is not productive. Productivity means that you provide profitability for the company, no matter what. Usually people don't go into the financials of an organization, but definitely to drive a very good Industry 4.0 roadmap, you do have to look into the financials of the factories. So another advice, sit down with a financial expert who exactly knows what P&L is, how the profit and loss is being calculated, what is being accounted. Sit down on the ERP, look at the goods receipts, POs. Those are really interesting areas to start. I was lucky enough to actually do that, and I gained a lot of interesting insight. For example, just a very example, right? And to keep it short, one of my first job was at this company, inventory management. We always had problem with inventory, meaning that we had always red, right? Now, the senior VP of this business unit, all right, Attila, you're pretty qualified for this one. Give us an inventory management strategy. What was interesting, I came back, oh, guys, we need more inventory. And everyone like, what?
Whoops.
Whoops. Are you really sure you're having PAs in this field? Fortunately, I did work with a university, so they were smarter people than me. Look at this point, right? What did I do first? I went to the financial and I asked the finance director, hey, how much money are we losing by this inventory? He said, no, none. As long as we sell the inventory, we have no problem. And we know we're going to sell these. Oh, by the way, our chips is nano size. So actually, in this office, I can store all our inventory. So I don't have inventory holding costs too, right? So just because it has a very high volume, right? It doesn't mean it actually financially impacts the company. Moreover, we figured that inventory can be a very nice leverage on or level to adjust our financials based on variances. And then I started to work in variances. Then you look at supply variance, you look at demand variance, you create your stock formula, and then you say, oh, by the way, let me see, given these variances, what is my optimum inventory should be? Well enough, 25% more. And by implementing 25% more inventory, we actually made a tons of money, because now I didn't have peak time, I didn't have hockey stick. Right. I could linearize my WIP, right? A demand change I could immediately meet. So I was the first in the market. we made a tons of money just by adding 25% inventory. Nobody with a very common sense would say this makes any sense.
Well, maybe not to an MBA, but maybe it does to somebody who understands theory of constraints, which is a
Correct.
reference to Goldratt.
Yes, back to the origins.
So, did you have any closing thoughts with us from your observations at the conference last week, or other things you'd like to leave us with?
It's really exciting to see the conference. I think looking at the PLM, where it is going, and what opportunity is really truly providing is there are tons of opportunities in PLM. There are a lot more focus at the engineering level on data analytics, data science, AI, but we have to understand we are working with physical models. We need to get back to the origin, just as Goldratt that's been since '86, which is how many years? My God, right? So
33.
Did not change, right? And believe me, physics will not change as well. So seeing the extreme amount of digitalization and integration in the PLM side, I'm really delightful, because that's where Industry 4.0 needs to go and expand. That's where digitalization comes in. That's what will improve a lot of productivity, greater productivity, product development capabilities, easier new product introduction, higher introduction yield, better product quality. How can I talk? This is exciting times to see PLM, the future of the PLM. So what I feel now that, us in factory operation engineering, we have to stop thinking that data science is the only way to improve product. No, not at all. It's just a tool. We have our beautiful tools under the PLM, which is extreme digitalization of our work items, and it will help us. And then we will use, machine learning, and we will use other tools to improve and add more productivity into your engineering activity. So that's where I see really, it's an exciting time now. A lot of focus on it, a lot of investing flowing into the area. And this is really paving the way toward Industry 4.0.
Okay.
So Attila, what's been great about this interview is sort of your optimism, and we love to have people on the show who are talking about, opportunities in the future. And I mean, that's what we're here for, right? And you said it clearly as you wrapped up there, that there is a lot of opportunities in PLM. There's a lot of opportunities in digitization. And that's what we're trying to do with the show, is show people that the future looks bright. And so thank you for coming on and sharing your point of view with everybody who's listening to the Digital Enterprise Society podcast. Thank you.
Thank you very much. I really enjoyed the interview. I'm really passionate about this field, and I truly believe this is a lot of engineering needs to be sexy. It's a sexy item, so let's work on it.
Engineering is sexy. That's the theme of the title of this episode, maybe.
I was thinking about make manufacturing sexy again.
I think somebody, I don't know. I'm not going to go there.
Okay, all right.
So Craig, thank you. Craig, any last thoughts?
Well, just for those of you out there that might not have followed what Attila and I talked about with Goldratt, just Google it. The cool thing about Google is you can find anything. You will find a few books. They're all worth reading. If you're an academician, you can get the Theory of Constraints book with all the formulas. Or if you'd rather just read a novel, Thom, this one's for you, then there's 3 books, and they read really well, and they talk about why would you ever improve a factory except for where the constraint is? And where do you know where the constraint is? Well, walking around and looking at your inventory may not be the answer. And that's what Attila was pointing out. Sometimes it's somewhere else. And so it's finding the constraint that's the real key. It's been a real pleasure chatting today with Attila. I did not expect the Goldratt reference. This is really fun. For the rest of the Digital Enterprise Society, we thank you for tuning in. We'll have more in the near future. And just remember, we're about connecting without boundaries and creating without limits. Thank you so much.
Absolutely. So join us next week, because we're going to be back with more thoughts, ideas, and information in and around the world of product lifecycle management. Thanks for tuning in, and we'll see you again.
Bye.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org.